Okay, now also talk about the next method of extraction we'll be looking at is infusion. Infusion is another method of maceration. But at times, this infusion can involve a little boiling and can also be done cold. But the difference between infusion and maceration is that infusion is just for a short period of time, like the way you do your lifting tea. You boil water, you just put the lifting bag for some time, like 15 to 30 minutes. So at times you want to drink your herbs, you just put it uh, as lifting, just infuse it. That infusion can also be in cold. Now we can also do infusion by just like oil, either water or oil. You can fuse with water, you can fuse with oil. If I want to infuse something like carrot, I can make my carrot to be cold and also just warm it a little. Okay. Another method is digestion. Digestion is another method, just like we talk about digestion and infusion, at times they can be confusing. When you're doing digestion, you're adding a little heat, gentle heating during the process of your extraction. But infusion, you're just doing your lifting tea. Okay? Either you soak in cold water or you soak in warm water. At times somebody can tell you these herbs, just soak it inside water. Okay, but not for a longer period of time. Whatever you're looking for, you get it. Just drink it cold because heat might affect it. And sometimes they can say use boiled water to do that. But when you're doing your digestion is another method of maceration, but you're going to just add a little heat during the process. And the solvents there can just, like I said, you can also use something like anything you're boiling, you can use water, but you can never use something like alcohol and do your digestion. You mainly use water. At times you can also use oil. Like I said, if you want to do something like plant material, you want to infuse them into oil. Either if you want to use normal cold infusion, it's going to take a longer period of time. So it's either you do maceration for that oil, and when you do maceration, make sure that your plant material is already dried, or you do digestion that by doing gentle heating. But when you're doing your infusion, you're just preparing your something like lifting tea. So that's another method. In the exam, you're expected to understand and distinguish between types of extraction technique you can use in natural products. So I always expect students to understand them so you can even put them down in your own words. Because if you just want to memorize, you're going to be confused. Maceration is cold method that does not involve any form of heat. Infusion can be cold or warm water or hot water, but it's for a short period of time. Example is a lifting tea. Digestion is another method of, all of them are maceration. But we have cold maceration. Infusion maceration is a shorter period, while normal maceration is a longer period. Then when you're doing something like digestion, just like I want to just at times, some people normally boil their lifting tea. You just put it inside kettle. As soon as it boil, bring it down because you're applying gentle heat. Or when you want to do your infusion, they say use double boiler for a just short period of time because don't want that heat to affect it. That's a digestion. But a higher method of heat is when you're doing your decoction. Decoction is the method you're preparing your agbo. That's the way the alago prepare the agbo. That's decoction. So in that decoction, you're going to boil. You're going to even boil it to even the water will somehow reduce. So you're going to boil and concentrate. So this is the method used in preparation of our agbo decoction. So we have talked about the four methods of preparation. Another method of preparation is percolation. Percolation is a situation whereby we call it a continuous flow of solvent through a bed of crude drugs. Okay, now if I want to percolate, I'm going to have a container or a vessel that has inlet and outlet. So that vessel, I'm going to close the outlet and soak my material with the solvent, cover it with the solvent. Let this stay for like 24 hours. If I'm using solvent, I can use as far as 72 hours. So when I'm ready, I'm going to open the outlet with a filter paper, then the solvent will be coming out. When it's done coming out, then I'm going to put another solvent. It will continue to flow until the solvent that is coming out become colorless. I'll stop the extraction method. So the difference between normal maceration is and the percolation process is that this one you're going to make it a continuous flow of the solvent until all the extraction process is sorted. That's percolation method of extraction. Okay, another method of extraction is susplet. Susplet method of extraction is used when you know that the compound you're looking for are not heat sensitive. So they will not be destabilized or destroyed by heat. In that case, you have your timbo. The timbo is the place where you're going to put your plant sample, while the solvent will be in the flask. So when the heating mantle will heat, it's going to heat the solvent, say ethanol. So when the temperature of ethanol gets to 78, it's going to start boiling. So when it starts boiling, you see that this ethanol will be evaporating. So it is going to pass through the vacuum and enter into the timbo. Then when and it's going to condense on the table, there's a condenser. So the condenser will allow it not to evaporate. So when it has condensed on the table, remember it's going to be hot ethanol. So this ethanol is going to soak this table. As soon as the table is filled, it's going to reflux back into the flask. So the process will continue. So in that case, all my extract is going to move from the timbo back into the flask, and the solvent will go back again into the timbo and extract, and it move by continuous until for a period of 4 hours, where you realize that, oh, this process is long enough. And you realize that the solvent that was in the flask that was colorless has become now colored and even concentrated. I'm not doing any filtration because this sample in the table is covered with wool or filter paper. So or put in something like mesh cheesecloth. So whatever I'm getting is already filtered. So remember, this method cannot be used for compounds. I know that the compound are heat sensitive. So it's a selective method. This is the susplet extraction diagram. Now, another method is steam distillation. Steam distillation is a method of obtaining our essential oil. We use steam distillation and we can use hydro distillation for essential oil. Remember, essential oil are essence aspects of a plant. And they are the one that when you talk about essential, you're talking about the aroma aspect of this plant. Whenever you're cooking your agbo and you have lemongrass inside, you know, somebody will only know that you're cooking agbo when they start boiling and the essential oil of this lemongrass will start evaporating. That's when it starts smelling lemongrass. Okay, that's the essential oil that is evaporating. Okay, now using steam distillation, that essential oil that was evaporating then will be condensed by a condenser and collected in the vacuum. Now, in that steam distillation, I'm going to have two flasks. One flask is going to have water, my sample, and will be heated. Another flask is going to be generating steam. So the flask one will be generating steam inside flask two. The flask two that have already steam. So the steam that is coming in with the heat coming on the flask is going to agitate the extraction of the plant material. And as essential oil is coming out, they will start evaporating. When they want to escape, condenser is going to condense them and they'll be collected in the flask. So in this method, I've collected my essential oil. In this case, I'm collecting it without solvent. Difference between this method and hydrodistillation is that in hydrodistillation, I'm collecting over normal hexane. So my essential oil will be trapped in hexane. When it's steam distillation, my essential oil is collected without solvent. So I don't have any issue of looking for a means of evaporating the solvent to obtain my pure essential oil. Let's ask our question as regards the extraction techniques before we continue. Questions? No question. Should I continue? My co-host to be my rate determining step. Should I, Matayo, should I continue?
Yes, ma'am.
So no question. Thank you. Please just, when I ask question, if there's nobody, please be their voice for today. Thank you. So we continue. Now, remember we've talked about how these phytochemicals are obtained from plants. That's where extraction method came to play. Now, we're going to talk about, remember beginning when we talk about essential oil. When we're talking about natural product, we talk about metabolites. And we said that part of some of the metabolites they contain are terpenes or terpenoids. And I said the difference between terpene and terpenoid is that terpenoids contain oxygenated compound, while terpene does not contain any oxygen. Okay, now we want to talk about terpenoids. Now, when we're talking about terpenoid, does not mean we're not going to talk about terpenes. So terpenes bracket terpenoid. And when we are talking about biosynthetic pathway, we talked about that these terpenoids are obtained from mevalonic acid pathway. So they are derived from mevalonic acid because that's their pathway. And they consist of isoprene units. Isoprene units. Isoprene unit is C5. So whenever you're going to get any compound here, you're going to divide them by their C5 to know whether they are monoterpenes, sesquiterpenes, diterpenes, triterpenes, or tetraterpenes. Okay. And I said that whenever they contain oxygen in their functional group, in the compound, in the form of alcohol, aldehyde, ketone, ester, ether, carboxylic acid, we call this kind of terpenes terpenoids. But when there is absence of oxygenated compound, we call them oxygenated functional group, we call them terpenes. So let's look at the classification of terpenoid. We have monoterpene. First, remember the unit of terpenes we are dealing with 2 mole of C5. So we call them C5 skeleton. Sesquiterpenes are 3 mole of C5. Diterpenes are 4 mole of C5. While triterpenes are 6 mole of C5. Then tetraterpenes, that's what you see in carotenoid. They are higher terpenoids. They are what we see them in 8 isoprene units. Anything that is higher than 8 isoprene units are regarded as rubber. Remember, rubber are pigments from plants, so they are from terpenes or terpenoids. Okay. Now, we'll be hearing about beta carotene as a source of vitamin A. So beta carotene is a pigment in carrot that can be a precursor for vitamin A, while lycopene is a pigment in tomato. So the color of carrot is because of the presence of beta carotene, while the color of tomatoes is because of lycopene. So lycopene is the active component in tomatoes. Now, these isoprene units are being joined together. Remember, like in monoterpenes, we have 2 isoprene units. So they're joined together by head and tail method. So the head and tail method. So this isoprene unit, the IUPAC name is 2-methyl butadiene. 2-methyl butadiene. If you look at it, you can realize that we have 2 diene, that is double bond at 2, and then carbon 1 and 2. Okay, and in that carbon 2, we have methyl. We have in carbon 1 and 3, 1, 2, 3. One, so we can call it 2-methyl but 1,3-diene. 2-methyl but 1,3-diene. So that is the IUPAC name of isoprene unit. They always join together by tail to head. Tail, you can see this is, look at head, look at tail. So another tail is connecting to another head. So head and tail, head and tail. Now, you must be able to understand precursors of terpenoids. Remember, we have monoterpenes, we have sesquiterpenes, and diterpenes. You should be able to understand the precursors of these terpenes or terpenoids. So the precursors are very important. Now, if I'm talking about the precursor of monoterpenes, the precursor of monoterpenes are geranyl diphosphates. Geranyl diphosphates. So for my C10, remember all the terpenes have a pathway called mevalonic acid, but each of them have their unique precursor. So for precursor of monoterpenes, we have geranyl diphosphate. Please make sure you're consistent with your spelling. As I'm pronouncing, make sure you're looking at the spelling. Geranyl and diphosphate. Then why that of sesquiterpene? That's when you have 5 isoprene units, you're going to have farnesyl diphosphate. When you have 2 isoprene units, you have geranyl diphosphate. But when you have 3, you have farnesyl diphosphate. Okay, another one is when we have our diterpenes or diterpenoids. We have geranyl diphosphate. Geranyl diphosphate. So please get used to this. Monoterpenes is geranyl diphosphate. Sesquiterpene is farnesyl, while diterpenes are geranyl. The secret of passing this course is constant practice. Make sure you are constantly practicing. Okay. So next is access terpenoids. Access terpenoid is geranyl farnesyl diphosphate. While I try terpenoids and steroids as squalene. This is unique one. Squalene is for steroid and triterpenoid. Triterpenoid and steroids are the same because triterpenoid are based on steroid. Who is disturbing this class, abeg? Who is this person? Okay, like I said, sesquiterpenes are from your geranyl farnesyl diphosphate. Why steroid? If you cannot remember anyone, remember that steroid is from squalene. Now, tetraterpenoid. Remember, tetraterpenoid are where you see your carrots. They are derived from phytosine. They are derived from phytosine. This squalene is very, very important. This is for your triterpenoid or steroid. Okay. How are these terpenoids or terpenes synthesized. You're not expected to know this in the exam, just for you to understand. Remember, we're talking about their pathway. So this is a reaction. You can see acetyl coenzyme A and malonic coenzyme A. Under Claisen condensation, you did Claisen condensation in your last in 322. So you're going to have acetyl coenzyme A, which undergoes adult condensation and subsequently we enter mevalonic acid. Remember, we said that mevalonic acid is the pathway for synthesis of terpenoids. We're not going to dwell much on this. Now, this is what you should know. These terpenes can be interconvertible, meaning I can use one to get another. Remember, we talked about in the biological system, there are reactions that are always going on. Okay, that will call it biosynthesis. Now, this is geranyl diphosphate. If you understand that for our monoterpene, the precursor is geranyl diphosphate. So this is geranyl diphosphate. So geranyl diphosphate is going to be converted to neryl diphosphate. Difference between the two is that one is trans while one is cis. Okay, then there will be an interconversion that is going to cause and lead us to limonene and alpha terpinol. So meaning that from my geranyl diphosphate, I can obtain limonene and alpha terpinol. Now, if you look at this limonene and alpha terpinol, you can understand that their carbon atom are carbon 10. That's why they are all monoterpenes. All the carbon atom are 10, and if you should be able to divide them into 2 isoprene units by head and tail, which is very glaring. When you divide them in from their center, you're going to get 2 equal halves, indicating the 2 isoprene units. So the mechanism is, as soon as the phosphate is going, we are going to bring, you can see when the phosphate is going, with reference to the mechanism you know about, when the phosphate is going, it's going to leave a positive center. And then when there's going to be a movement of the double bond to close the ring, then in the presence of a base, we are going to form another double bond. In presence of an acid, we are going to form another. So whatever you're going to form is respect to what's up. If I'm looking for double bond, I'm going to use a base. A base is going to abstract hydrogen to form double bond. But if I want to add water into the system, it means I'm going to get alpha terpenol. I'm adding oxygen into the system. So from my limonene, I can also get my alpha terpenol. They are all coming from geranyl diphosphates. So you might be asked to derive limonene and alpha terpenol from geranyl diphosphate. Another thing you should understand is structures of monoterpenes. We have in monoterpenes, we have the one that has closed ring. We have the one that are open ring. Now, in closed ring, we call them cyclic. And that cyclic, we can also have bicyclic. We have monocyclic, we have tricyclic, we have bicyclic. A bicyclic has 2 rings, while mono have just 1 ring. A typical example of monocyclic you're going to always remember is limonene and alpha terpenol. They are all monoterpenes. Remember, limonene is monoterpene, while alpha terpenol is monoterpenoid. I hope we are used to the difference now. So you look at it from my mycene, I can get from my mycene that you can also derivatize, okay, to obtain other compounds, which we're going to see in subsequent slides. Where we have bicyclic. Bicyclic is made up of 2 rings, okay, which is even evident from the structures. We have 3-carene, alpha-togene, and alpha-pinene. These are bicyclic compound because they have 2 distinct rings. And we also have trisilene. Trisilene is a typical example of tricyclic. It should be conversant with the monocyclic. It should be able to give us at least 2 examples. Must make sure you give us 2 examples of monoterpenes. Okay, beside monoterpenes, remember the classification, we also have another class of terpenes apart from monoterpenes. Okay, let's continue. Now, we are still on monoterpene. Now, in monoterpene, we have cyclic or acyclic. Mycene and geraniol is a typical example of acyclic. Acyclic is when the ring is not closed, while cyclic is where the ring is closed. So in cyclic, we have alpha terpene, we have cinol, we have togene, we have carbone, we have menthol. This is the structure of the menthol. Whenever you're eating your chewing gum, you want it to have mint. This is the structure of your menthol. As an organic chemist, you'll be able to know some of these small structures. Menthol has hydroxy group. That is why it can serve as antioxidants. Okay, that's why it can inhibit some microbes because of the presence of that phenolic. Okay, making it an antioxidant. So when this menthol undergoes oxidation, you're going to form menthone. Okay, so geraniol can also be called geraniol. We're going to see it in the next slide. That we can have interconversion of geraniol and geraniol, nerol and meral. Difference between them is cis and trans, which is important that you understand. Okay, we have this acyclic oxygenated. Acyclic oxygenated. In previous slide, we are talking about normal monoterpenes. And these monoterpenes, you can see we have acyclic. The first one, mycene, is monoterpenes, while geraniol is monoterpenoid. Alpha terpene is terpenes. Then togene, carbone, and others are all monoterpenoids. In this particular slide, we have only 2 monoterpenes, which is mycene and alpha terpenine. But here we are talking about all terpenoids, because they have all oxygenated. Now, if you look at what I was saying before, is look at geraniol, look at geraniol. So in this slide, if you know one, in fact, with knowledge of how the structure of geraniol, you can be able to predict geraniol, you can be able to predict nerol. I can also be able to predict neral because all of them are cis and trans. Geraniol and neral are isomers, while geraniol and neral are also isomers. So with this, I have structures. Now, if the question they said more monoterpene, it means it can give us whether cyclic or acyclic, except the question is monoterpenoid. When they say monoterpene, you can give us terpenoid, you can give us normal terpene. But if the question is monoterpenoid, you cannot give monoterpene. It must be oxygenated. But if they say monoterpene, you can give oxygenated or non-oxygenated. You will not be penalized. I want you to understand that. Terpenoid are more specific. Terpene can be generalized. So whenever you're talking about terpenoid, you must make sure there is oxygen. Okay. So, and whenever, now the essence of this, why essential oils we are talking about are very medicinal, is either because of unsaturation, which is presence of double bond, or phenolic compounds. So these are what made them to be very essential or beneficial for well-being. Now, the geraniol, moving to geraniol, simply underwent oxidation. The same thing with neral, moving to neral. a simple oxidation. So a simple reaction of oxidation, which you can use permanganate to achieve your aim. Okay, so that's for monotapenoid. We've talked about, so at this stage, you should be able to give us examples of two cyclic or two acyclic monoterpenes. Like I said, monoterpenes, you can use oxygenated or non-oxygenated. We are going to bicyclic, mono and bicyclic, or whatever we've been doing is the one that the ring is not closed. We call it acyclic. Now we're going to the closed ring, making it bicyclic. Closed ring is cyclic, so that side can be one ring, we call it monocyclic. Two rings, we call it bicyclic. A typical example of mono, what we'll talk about is mentone or menthol. So if I know my menthol, I've known my menthol because simple oxidation. Okay, and you might not be expected to write more than two examples of all these classes. So whenever you want to learn, please don't go and learn the one that is very difficult. You cannot please, you're not trying to impress anybody. Whenever you come to exam, don't look for a means of impressing. Nobody wants to be impressed. So as long as it depends on you, choose the one that is easy, that you can easily relate with. Don't go and start cramming something that's ambiguous. Where there are simple ones you can optimize. So leverage on what is simple and just put in your best for the exam because the exam is not difficult. So we also have camphor. Camphor is not a difficult one. Even if you want to use a normal structure other than the shear structure, you'll be fine. So that is our mono or bicyclic monoterpenes. I also want to advise us as soon as this course have started, because this course have started and you're interested in writing this A course, I want to encourage you to go and look for the past questions. Past questions is always good for you to look at past questions even before you enter exam. Or the benefit is that when the class is going on, you'll be remembering how the questions are being framed. So it's going to give you idea of what the examiner is expecting from you. So from day one, like I normally advise, please start reading now. You have some of these slides. Start reading now. Don't wait for when they said, we are planning for tests in 2 weeks. You start reading. That's what some of us that don't like crash program. When there's impromptu test like that, see them failing. And remember, in this your ultimate year or penultimate year, depending whether your course is 4 or 5 years, every half mark goes a long way. So don't be careless and said, after all, what I wrote is enough to give me A. You're not the assessor. So make sure you give as much information as you have. Don't hold anyone. Okay? The most important thing is for you to understand natural product, use it in your daily life, and also do well in the exam. So we're talking about mono and bicyclic terpenoid. So this is another example of bicycle. If you look at it in my Tujun, you can see the ring, how the ring were divided. Okay, verbanone, you can also see how the ring are divided, and all this amphenchone. So these are all bicyclic terpenoids, bicyclic monoterpenoids. Why are they monoterpenoid? Because they have the ring system of carbon number 10, indicating 2 isoprene unit. Okay, I think we're going to stop in the properties of this. Okay, let me just do a stop in synthesis of camphor. Okay, the physical properties of this monoterpenoid, you talk about their melting point, they're mostly liquid. That's why I see essential oil are always liquid. Most of them are liquid. Meaning, when you talk about liquid, the liquid does not melt. It's already in liquid form. That's why the melting point is -15. Okay, it's only camphor. Remember the structure of camphor. Camphor is still the same camphor we see. We talk about camphor balls. That's the only one that is solid at room temperature. That's why I say camphor balls. They're essential oils. And remember, those ones are good for insecticide. Okay, boiling point. Alpha point pinene has a higher boiling point of 156, while nerolidol has a higher one of 276. In terms of solubility, they are all soluble in organic solvents. But remember, these are water. So they can never be soluble in water. These are oil, so they can never be soluble in water. They are insoluble in water. Okay. Monotapenoid, organic solvent with some limited water solubility. Now, monoterpenes are organic solvents, while monotapenoid, they have also limited solubility in organic solvent. Remember, organic solvent will, sorry, while monotapenoid, all tapenoid are soluble in organic solvents. Now, every phytochemicals are soluble in organic solvents. It's only some that are limited with water. Now, whenever you want to do extraction, the best way of getting your extract is not using water. Water has limited solubility. The best method is using aqueous ethanol, so that what water cannot extract, the ethanol can extract it. Because remember, in essential oil, we have lipid, and water cannot extract lipid. So whenever you want to do your crude extraction, that you're interested, maybe as a drink, as a herbal tea or whatever, optimize aqueous ethanol. Except when it is affecting your health, like people that have problem of diabetes or high blood pressure. In that case, you can use alcohol as a preservative in a very small quantity, something like 10-15%, to preserve your extract. Oh, lastly, for today is how does this monoterpenes occur? Occurrence, they are always obtained from both animal and plants, even terrestrial and marine. You talk about algae, you've heard about algae are obtained from the sea. So they are all plants that we can obtain essential oil from. They are also very distributed in higher plants. That's why you can see something like roots. When they are cooking, it starts smelling. You start smelling all the parts of the plant. They have essence of the oil of the plant. Call it essential oil. Among trees, you can feel essential oil in softwood. Sometimes when you go to this place that are doing wood, there are people that are selling wood for building. That place will be smelly. It has its own smell. That smell that you're perceiving there is essential oil from that wood. So we also have some essential oil that are formed in oleoresins. Animals are not exempted from essential oil. So plants and animals are common alike when you talk about essential oil. But the truth is that essential oil is the essence aspect of the plant, the animal, even some human being get essential oil itself. There are some people that when you go close to them, they have smell. But every human being have its own unique smell. But there's some people have odor other than smell. That's when it become bad. So we are going to continue the next class on Monday via talking about synthesis of camphor. I know that we all have this slide because your predecessors would have given you this slide. So if you have it, make sure you go through the slide. Okay. Some of you did not submit the assignment on time. So in every class, I'm going to stop by quarter two, so I'll use the remaining time for classwork. So as soon as it's 3:05 or 3:10, I did not submit classwork. People that are submitting late, it's only a matter of time. On the day of reckoning, it will be as good as you were not there for the class. That's why I did not submit. But anybody that is there for the class, some questions is not what to take you for more than 10-15 minutes. I don't know why people will be submitting a classwork by 5 p.m. when the classwork is meant to end by 2. So people should be very careful. My co-host for today take down the questions. If the course rep is around, course rep can take down. So everybody can take down, but I want somebody that can share it on the platform. So the co-host of today, please share it on the platform. Question number 1. Distinguish between any 5 types of extraction method you know. Any 5 types of extraction method you know. List and differentiate between the 5 types of extraction method you know. Question taken. Should I continue?
Yes, ma'am.
Number 2. Dash is a biosynthetic pathway of terpenoids or terpenes. Dash is a biosynthetic pathway of terpene bracket terpenoid. That's one is 1A, this one is 1B. Then 1B, this 1BI. 1BII lists the precursor of the following terpenoid: monoterpene, diterpene, steroid, and carotenoid. Monoterpene, diterpene, steroid, and carotenoid. They are precursor. They are precursor. That's so number 2. This is classification of terpene bracket terpenoid with examples. Classification of terpene bracket terpenoid with example. That's 2A. 2B. Draw and name 3 examples each of cyclic, acyclic monoterpenes. Cyclic and acyclic monoterpenes. Remember, I said whenever I say terpenes, it means terpene or terpenoid. Are the questions taken?
Sorry, ma. Question 2B again.
Mm.
Who got the question? Question 2. You know, I did not write the question anyway.
The classification
Question.
of terpene.
Okay, classification of terpenes with examples. No, classification of terpenes with their isoprene units. Classification of terpenes with their isoprene units. Classification of terpenes with their isoprene units. While the 2B is talking about 3 examples, structure and name of mono and bicyclic terpenes. Now, remember I say mono and bicyclic, right? Now, I did not say the mono should be cyclic. I did not say the mono should be acyclic. So anyone is fine as long as it's monoterpene. So if you want to use acyclic, use acyclic. If you want to use cyclic, use cyclic. Let it be monoterpenes, okay, and bicyclic. So we have monocyclic and bicyclic. Any question?
Sorry, ma, I did not understand the last question. Initially, you said we should name 3 examples of cyclic and acyclic monoterpenes.
Let's go that way. Cyclic and acyclic, 3 examples each.
All right, ma.
Okay, cyclic, acyclic, and bicyclic. cyclic, acyclic, and bicyclic. So we cover everything. Please, can you share the questions on the platform so I can fill it on the Google Classroom? You have like till 2:20. 2:20. After 2:20 becomes late. Okay, let me give you 2:30. 2:30 is the deadline for submission. So do your homework and submit it.
This is
You're going to
253, ma'am.
Sorry?
This is 253.
I said okay, 3:30. Sorry, 3:30. We have to you have to at least let me give you like good 30 minutes. Please share the question on the platform so I can attach it to the Google Classroom. Thank you. We'll see you on Monday. I don't know if there's any way we can. I don't like afternoon class. If it's adjustable, check within yourself if there's any way we can adjust this afternoon class. If we cannot, we'll manage it. If there's any way we can adjust it, better. Thank you. I have class.